What's going on, guys? All right, we're going to go ahead and talk about solving simple equations today. That's what the lesson's going to be on. So go ahead and get your comp books out, and this should be the title that you put in your composition book. Remember, you can pause me at any time and rewind if you can't hear me or understand me well enough. All right, today here's learning objective. Solve linear equations using addition and subtraction and also multiplication and division. So those are the objectives today. All right, here's some vocab. Vocab is pretty important. I want to be able to use these words whenever I talk to you guys, whenever I describe things. And so make sure that you write this vocab down. And if you're confused by anything, send me an email and let me know. All right, variable. You've heard this before. Usually the letter X or N is used, but it's a symbol that represents an unknown number. It is unknown, so they use a symbol instead. In one problem, if you're using X, then once you solve for X, you know what X is for the problem the entire time. It can't change even if you have another X in the problem. So it's really cool. All right, expression. Expression is a math sentence, basically. There's a couple examples you can see there on the screen, like 5 plus 4 or 3x minus 6. Those are some examples. But there's at least two numbers and at least one math operation, such as addition, subtraction, multiplication, or division. All right, next is equation. It's a statement that says that two expressions are equal. So basically it has an equal sign. That's how you know it's an equation. An equal sign literally means equal. If you look at those two expressions, 2x minus 6 and x plus 1 on your screen, and there's an equal sign between them, it means that those two sides are the exact same. So you're trying to find what x equals that makes those two expressions actually equal each other. So that's what an equation is. A solution is your answer. So that should make sense that the word solution is the same thing as your answer. It's the number value that you're associating with your variable that makes the equation true. For example, up top, again, where I said 2x minus 6 equals x plus 1, the x value that made those equations equal to each other, or sorry, those expressions equal to each other, is called the solution. So if you look down below, it says if 2x equals 6, then x equals 3. 3 would be your solution. And so if you plug in 3 for that x value there, 2 times 3 does equal 6. So indeed, 6 does equal 6. All right, inverse operations. I'm going to be using this. These are two operations that undo each other. They're basically opposites of each other. So addition and subtraction, they're opposites of each other. And multiplication and division, they're also opposites or inverse operations of each other. So you're going to use the inverse operation to undo things. All right. So we're all done with the vocab. Yay! I want to talk to you guys about PEMDAS. I know you guys have heard of PEMDAS before, but I tend to write it a little bit differently than you may have seen it before. And so I want to talk about that. So go ahead and make sure that you write it like this on your paper. Once again, pause if you need to. But if you don't know, of course, P stands for parentheses, E for exponents, M is multiplication, D is division, A is addition, and S is subtraction. So write those down if you didn't know, or if you forgot a couple, you can go ahead and write those down. But the question is, why do I put M and D together and A and S together? Well, one doesn't come before the other. They are literally the exact same thing. Multiplication, division, and addition and subtraction are the same as each other. So I like to write it like this. There's also one more thing that I like to write, and it's this. So That stands for left to right. So as long as you follow the order of operations, or PEMDAS, you need to go in the order from left to right next. Okay, so there's your PEMDAS. All right. All right, so let's get into our first problem that we're going to talk about and solve. So I want you guys to definitely take notes on how I solve this problem, or I'll give you two problems. And then you are going to do a couple on your own to make sure that you know how to do what I'm talking about. All right, here we go. So first problem, x minus 3 equals -5. Just solve the equation. So solve means that you need to find out how to make these sides equal to each other. You're literally solving for the variable. And in this case, the variable is x. So make sure that you look at x and say, okay, at the end of the day, I want to know, what does x equal? That's what we're solving for. Okay, what does x equal? So the only way to do that is to make sure that we are getting x all by itself. That's the ultimate goal. So the ultimate goal is to isolate the variable. And remember, isolate means to get it all by itself. So to isolate the variable, we have to get rid of everything that's on the same side of the equation as the variable, because we want to get it all alone. So if you look at that equation up there, what don't we like about it? What is on the side with the variable that we don't like? And the answer is that -3. We don't like that it says x minus 3. So if there's a -3 there and we want to get rid of it, what is the inverse operation of -3 or -3? +3. So make sure that you're just adding 3 to both sides. And this is what happens. You can do whatever the heck you want to any equation as long as you do it to both sides. So I'm going to go ahead and add 3 to this side of the equation and add 3 to this side of the equation. And some people like to teach their students to look at the equal sign and draw a line down like this to remind yourself that you have to do something to both sides and you can't just cross over unnecessarily. Okay, so I'm going to go ahead and draw that line this time. Now we're going to go ahead and solve this. If I added 3 to a -3, what happened? Well, that canceled out. Wasn't what I was trying to do at all. Here we go. Let's try that again. Nope. 1 second here. All right. So they cancel out. I'm still learning, obviously. All right, they cancel out. So what's left on this entire side of the equation? Just x is left all alone because these 3's canceled out. And this equal sign always stays. And now we solve this. -5 plus 3 is -2. So now we have x all by itself, and we have everything on this side simplified. So what does x equal? X equals -2.
-2.
So -2 is your solution. That was what we were looking for. Now, here's what I like students to do, and a lot of times you can just do this in your head, but I'm going to go ahead and do this on the side. Remember that our original equation was x minus 3 equals -5. And we're saying that x equals -2. So that means everywhere we see an x, we should be able to replace that x with a -2. And this is how you know if your equation's right or wrong. I mean, if your solution is right or wrong. This is you checking your answer. So we plugged in x right here, -2. Those are the exact same thing. We already solved for it. And now we solve this side. So what is -2 minus 3? Good, -5. And this side remained -5. Now, is this statement true? Does -5 equal -5? Yes, it is true. So once you get that true statement, because you plugged in the x value you found and you showed that both sides do equal each other, whenever you use your solution, you know you got it right. All right. So now we're going to go ahead and do another problem. So let's go ahead and move down a little bit, and I'll do it down here. All right, the next problem, I'm going to use decimals. Throw you guys a little curveball here because it works with every number. And I got back on the eraser. All right, here we go. 0.9 equals y plus 2.8. All right, a very similar problem. If you want to pause it and try first before I do it, go ahead. Otherwise, here we go. So I don't like the 2.8 over there. So I want to get rid of it. I'm going to do the opposite of whatever it's doing. It's a positive 2.8. So I'm going to subtract 2.8. Remember, you have to do it to both sides. So now these 2.8 cancel, and I'm just left with y all by itself. And 0.9 minus 2.8 is -1.9. And looky, looky, we got y all by itself. That was the goal here. And so really quick, let's just go ahead and prove that that's true. So this side, 0.9 equals, I go ahead and plug in a y, -1.9 in for y, -1.9 plus 2.8. And if you toss -1.9 plus 2.8 in your calculator, what do you get? Well, hopefully you get 0.9. And you do, which means our solution was correct. All right, here are some practice problems that you can do. So make sure you take a look at these and give them a shot on your own. Pause the video, and I'll give you the answers after you're done. Here are the answers. Make sure you give them a check. Celebrate, give yourself a pat on the back if you got them right. And if you didn't get them right, make sure you put a question down that you're going to ask me during office hours so I can help you figure out what you may have done wrong. All right, so the next thing that we're going to do is we are going to go back to the whiteboard so I can show you guys how to do multiplication and division. So I'm going to give you a couple problems here that we can do together. And the first one will be multiplication. So I'll give you a nice easy one. So let's say 4x equals 8. A very simple problem for you. So you look at that, we're trying to get x by itself once again, and you ask yourself, what are we trying to get rid of? Well, the 4 next to the x. And what is that 4 doing with the x besides just hanging out? It's being multiplied. So what's the opposite of multiplying something by 4? You all said it. Divide by 4. So make sure you do it to both sides. Cross those out. And what's left? X equals, and 8 divided by 4, 2. We found our solution. Make sure you guys plug it in. See if you get it right. Remember, the original equation is 4x equals 8. 4 times 2 equals 8. We just plugged this in, right? And 8 equals 8. Ding, ding, ding. Our solution of 2 was correct, and we just verified it. All right, let's go ahead and do the next problem. It could even be values that are not numbers, but I'll skip that one. Let's go ahead and just do a division problem. So That was multiplication. Here's division. Division is automatically scary because you guys see a fraction. So negative n divided by 5 equals negative 3. Now the trick to this one is I would realize that this negative sign for any fraction could just be written in the middle, or it could be written on the bottom, or it could be written on the top. And guess what? These are all the exact same thing. So you might want to put that. So make sure you write this in your notes, because this works for every fraction. It's a really good thing to know. So with that being said, let's just go ahead and rewrite the problem. Negative n divided by 5 equals negative 3. I want to change it to make the 5 negative, so I can get rid of it and I have an n that's all positive. So we're going to rewrite this as n divided by negative 5 equals negative 3. And now we're good to go. So n divided by negative 5, how do you think we're going to get rid of that negative 5? We're going to multiply both sides by negative 5. All right, and then this cancels. That was the whole point. Dividing and multiplying cross each other out, and we get n by itself. And negative 5 times negative 3 is positive 15. Good. Side note, it makes me a little sad that I don't get to hear you guys yelling those answers at me during class. So now all we have to do is check. Is positive 15 divided by negative 5, because I plugged this in instead of n, right? Is positive 15 divided by negative 5 the same thing as 15? Okay, I obviously screwed that up. Oh, no, I didn't. Is positive 15 divided by negative 5 the same thing as not 15? That's where I screwed up. The value there was 3, right? The negative 3. There we go. So we had to rewrite the equation. Is it the same? Yes, it is. Negative 3 equals negative 3. If I just confuse you right there, let me know. I'll fix it for you. All right, so with all that being said, go ahead and check out these two practice problems. Problem number 1 looks kind of ugly. You can rewrite it on your paper as y over 3, the same as the practice problem that we originally did, or my example, I should say. And then the next problem is pretty self-explanatory. So go ahead and pause. All right, and then here's the answers. If you didn't get those answers, go ahead and come see me in office hours and we'll talk about it. I'll definitely help you out there. All right, guys, this concludes my first lesson. Hopefully you were able to understand everything. Hopefully a lot of this was review. Let me know if you have any suggestions for me. This is my first video making by myself. We'll all learn together and I'll definitely get better for you. See you guys next time.